In this video, I am going to solve the problem 21st from chapter 19. Suppose 0.825 mole of an ideal gas undergoes an isothermal expansion as energy is added to it as heat Q. If figure shows the final volume Vf versus Q, what is the gas temperature? The scale of the vertical axis is set by Vfs equal to 0.30 meter cube, and the scale of the horizontal axis is set by Qs equal to 1800 joules. Okay. So first of all, I'm going to write what is given in the question. So in the question, they mention the number of moles of the ideal gas. So what is the number of moles of the ideal gas here? So N takes the value here as 0.825. And they mention the reaction, the process name, isothermal expansion. So I have to write isothermal, right? Okay. And here they gave the figure graph, the volume versus the heat. And they set the maximum value for the volume here as 0.30 meter cube. Likewise, the heat in the x-axis they mention as the maximum value setting as 1800 joules. Okay. Now, what we are going to find, we are going to find the value of the gas temperatures. That means we are going to calculate the value of the temperature. So the process name they mention isothermal. So if it is an isothermal, what should be the condition? The change in internal energy must be equal to zero. So first of all, better I can write the first law of thermodynamics as we already studied in the theory class. Q equal to, that means the amount of heat energy given to the gas, which is equal to the change in internal energy plus work done, right? So in isothermal condition, your change in internal energy is equal to zero. So when you substitute the value of this internal energy as zero, what should be the final answer? Your Q, which is exactly equal to the work done, right? Okay. Now, better I can just come for the figure. We have to identify what should be the value for each boxes. So here in y-axis, we mentioned the maximum value for the final volume as 0.3. That means each two box takes the value of 0.1 meter cube, and this one is 0.2 meter cube, right? Likewise, here we have the maximum value of the heat energy as 1800. So each box takes the value of 300. So you have to see here, this is 300, and this one is 600. This one is 900, 1200, 1500, and the final one is 1800. Clear? So that means in x-axis, each box is incremented by 300 joules. Likewise, in y-axis, two boxes are incremented as 0.1 meter cube. Okay. Now we are going to find the value of the temperature. So for that, I have to use the formula for W. Why? Because we don't have any formula for the isothermal condition for the heat energy, but we have the rule. The work done for the isothermal condition will be given by the rule nRT natural log of V final over V initial, right? So here the condition Q, which is exactly equal to W. So I can take the formula for Q here because Q is equal to W. Therefore, Q is equal to nRT natural log of Vf over V initial. So I'm going to write Q is equal to nRT natural log of V final over V initial. So why we just took Q equal to W? Because in isothermal condition, your change in internal energy is equal to zero. When you substitute that value of internal energy as zero, you will get Q equal to W. So I took the formula for work done as heat. Clear? Okay. Now we are going to find the value of the temperature. But before that, we have to identify what should be the final volume, what should be the initial volume. So here, the isothermal graph is given here. You have to see the initial volume is exactly started here, right? You can see the initial volume exactly start at 0.2 meter cube. And the final volume is exactly finished here. Even though you will get some graph extended more than this 0.3, but we have to consider the maximum value allotted for the final volume as 0.3. So that means it starts at 0.2 meter cube and it's end with 0.3 meter cube. That means here our initial volume is taken as 0.2 meter cube and our final volume should be taken as 0.3 meter cube. And in x-axis, the maximum value for the heat is given as 1800. So we no need to bother about this. So we have to consider only up to the V final. So what should be the heat energy up to this? Our heat energy for this maximum value of the volume, which is exactly 1500 joules. Clear? So we have to take the maximum volume with respect to its heat energy. So here 1500 makes the volume to 0.3 meter cube. Right? Okay, so I can just write here. So Q here is 1500 joules, and then here the final volume is the maximum volume as 0.3 meter cube, and your initial volume exactly start at 0.2 meter cube. So now I have to rearrange this equation because we are going to find the temperature. So therefore, if you rearrange this equation in terms of temperature, temperature T equal to Q over N or natural log of V final over V initial. Now I am going to substitute the value here for getting the answer for the temperature of the gas. So therefore, T equal to our heat energy here is 1500, right? So 1500 over the number of moles of gas, which is already given in the question, which is 0.825 mole, right? So I have to use this value for N, 0.825, 0.825, and the ideal, gas constant value is 8.314 multiplied with natural log of our V final is 0.3, our V initial starts at 0.2, right? So now I'm going to calculate. I got the answer here as T equal to 539.35 Kelvin. So this is the answer for this question. That's it. Thank you.